In the previous video, we've talked about the classification of states. There are several categories. Now we are going to use them to define a special type of Markov chains, which is called an ergodic chain. Let's see what it is. We have an ergodic chain if all states in the chain are recurrent, aperiodic, and communicate. So to refresh what these all categories mean, recurrent means that the states are not transient. Transient itself means that if you are in state I, you may go to another state J that is reachable from I, but then you cannot go back to I because I is not reachable from J. So that is transient. If that is not the case, then the state is called recurrent. And then aperiodic means that from state I, if you find the number of ways to go back to state I itself, the number of steps is not always a multiple of a number k, which is k greater than 1. If that is the case, then the state is aperiodic. And finally, communicate means that two states I and j, they are said to communicate if j is reachable from I and I is reachable from j. In other words, there is at least one way from I to j, and then there is at least one way as well from j to I. So if all the states in the chain satisfy all these categories, they are all recurrent, aperiodic, and communicate, then the chain that we have is called an ergodic chain. Let's see these three examples of transition probability matrices and see if each of them is an ergodic chain or not an ergodic chain. Remember that to be an ergodic chain, all states must be recurrent, communicate, and aperiodic. So for the first one, let's try to draw a graph to describe the transition probability. And then you can see here that all states are recurrent because you can go anywhere and then return to where you started. And then it means also they all communicate. And also it is aperiodic because, for example, if you start from 1, you can go back to 1 in 1, 2 steps. So 1 to 2, 2 to 1. You can also have more than 2 steps, like 1, 2, 3 steps. You can also have 4 steps, for example, 1 to 2, 2 to 3, 3 to 3 again, and then 3 to 2, 2 to 1. I think that is like 5 steps. 1 to 2, 2 to 3, 3 to 3, 3 to 2, 2 to 1. Okay, so you can check that for all states it is aperiodic. For the second transition probability, you can see something here that is not satisfied. For example, 1 and 4, they do not communicate. You cannot go from 1 to 4. So obviously it is enough to say that this is not an ergodic chain. Another example, 1 to 3, they do not communicate as well. As long as one requirement is not satisfied, then the chain is not ergodic. For the third one, you can also see that all states are recurrent. You can go anywhere you want and then return to where you started. So they all communicate, and there is no period as well. So this is aperiodic. So this is also an ergodic chain. You may wonder why this ergodic thing is really important, like why I put it in a separate video instead of together with all the classification of states in the previous video. Well, this will be clear when we're talking about steady state probabilities in the next week. So keep in mind that we need to know whether a chain is ergodic or not because it is important and it will be used later to define the steady state probabilities. As usual, here are some questions to check your understanding, and I will pause the video and give you the answer after that pause. So given a graph of a transition probability and also the transition probability matrix itself, is the chain ergodic? Remember that to be ergodic, all states must be recurrent, communicate, and aperiodic. The answer is no. This chain is not an ergodic chain because, for example, 1 is a transient state. If you leave state 1, you go to state 0, you may never be able to return to state 1. So state 1 is a transient such that this chain is not ergodic. Given another transition probability matrix and transition probability graph, again I ask the same question. Is this chain ergodic? The answer is again no, it is not ergodic. Because for example, 200 and 011, they do not communicate. So 011 is reachable from 200, but not the other way. You cannot reach 200 from 011. The reason is that because this probability matrix is taken from the example of choosing a ball from an urn. Once you've had one ball is painted red and another ball is painted black, you simply cannot return to have two unpainted balls. You cannot unpaint the ball. So that's why there is no path to go from 011 to go to 200.